Hi, algebra students. We're going to continue our study of radicals. And we're getting into the heart of the chapter. This is the interesting part, the fun part. We're going to learn how to multiply, divide, and simplify radicals. Okay, so let's talk about multiplying radicals. A little bit of this is review. We have the square root of 6 times the square root of 6. We're going to apply the product property of radicals and put them both under the same radical, which becomes the square root of 36, which is 6. You know how to do that. Let's look at one a little more complicated. The square root of 3x times 4 the square root of x. Well, the 4 is outside the radical. And that is going to stay outside the radical. And then we're going to combine the square root of 3x with the square root of x under the same radical using the product property of radicals. That becomes 4 times the square root of 3x squared. Well, the square root of 3x squared can be separated into the square root of 3 times the square root of x squared. This cannot be simplified, so it will stay the square root of 3, but the square root of x squared is x. And we get 4 times the square root of 3 times x, or 4x, to the square root of 3. When we're writing our the part of the term in front of the radical, we don't use any sign in here, okay? I think I noticed somebody doing that. Okay. Let's try another one. The square root of 7xy squared times 3 the square root of x. Well, again, the 3 is outside. We're going to leave that outside. We're going to combine what's under both radicals and put them under one radical. And we're going to get 7x squared y squared underneath that radical sign. Well, the square root of 7 can't be simplified. We're going to separate them into the square root of 7 times the square root of x squared times the square root of y squared. The square root of x squared is x, the square root of y squared is y. Those will stay in front of the radical sign, and the square root of 7 will stay. That's not too bad. Let's try the quotient property. Okay, we want to simplify the square root of this fraction, 13 over 100. Well, we need to recognize that the 100 in the denominator is a perfect square. So we're going to use the quotient property of radicals, which states that the square root of a quotient is equal to the quotient of the square root of the numerator over the square root of the denominator. So we're going to change that form to look like a square root over a square root. And of course the square root of 100 is 10, and we are left with the square root of 13 over 10. The square root of 7 over x squared. We're going to do the same thing. Change it to the square root of 7 over x squared, and you're going to get the square root of 7 over x. If I'm talking too fast, slow this down or repeat the video. I don't want to go too slow because it's going to make my file too big. Here's some guided practice that I want you to work on. Okay, I'm going to freeze that for a second. Freeze your screen and work on those, and I'm going to pop up the solutions to those. Here we go. Let's get the first one. 2x cubed times the square root of 2x cubed times the square root of x becomes 2x to the 4th. X to the 4th is a perfect square of x squared, so the x squared comes out front, and we're left with x squared times the square root of 2. The next one is not so bad. The square root of 1 over y squared becomes the square root of a numerator over the square root of the denominator, and the square root of y squared is y. That's not so bad. The next one's a little bit trickier. Okay, we've got a product here Here's the rest of it, okay? Now, this 3 and this -2 are outside radical signs, so they're going to combine to be a -6 in front of the radical sign. We're going to combine everything else. We're going to combine this and this under the same radical sign. We get a squared b squared under the radical sign. Well, the square root of a squared is a, and the square root of b squared is b, so we're left with -6ab. Now we need to talk about simplest form. Please make sure you read this entire section in your book before you go and do your homework. A radical expression is in simplest form when no integral radicand has a perfect square factor other than 1. Okay, integral is referring to an integer. So the square root of 4, obviously, is not in simplest form. The square root of 8 is not in simplest form because it has a factor that's a perfect square, 4. No fractions are under the radical sign, and no radicals are in the denominator. You must meet all those requirements to be in simplest form. Now let's take a look at a problem. Let's simplify the square root of 75 over 2 the square root of 18. Well, the square root of 75 has a perfect square in it, right? It has 25, so we're going to separate that, and we're going to take out that perfect square. The square root of 18 also has a perfect square in it, being 9. So let's take a look. Square root of 75 simplifies to 5, the square root of 3. The square root of 2 times the square root of 18 will simplify to 2 times, if I look at this square root of 18 right here, it becomes 3 the square root of 2. Because it's the square root of 9 times 2, the square root of 9 comes out as 3. And we're left with 5 the square root of 3 over 6 the square root of 2. Well, we have a problem. That's not in simplest form according to our rules. Why not? I hope you can answer that because we have a radical in the denominator. What can we do? I want you to think about that while I go to the next slide. Pause it and think about it. We must get the radical out of the denominator. How are we going to do that? Think about all the tools you have in your toolbox. What can we use? We're going to do what's called rationalizing the denominator. How can we get a denominator that's an integer? Well, the only thing we can do to a fraction is multiply it by 1. We're going to multiply by a form of 1 that accomplishes this. So what is that form of 1 going to look like? And I hope you guessed it, the square root of 2 over the square root of 2. So let's look at this. We left off here, okay, with 5 the square root of 3 over 6 the square root of 2. We're going to multiply by the square root of 2 over the square root of 2. This is a form of 1. We can do that without changing the value. 5 the square root of 6, 6 the square root of 2 times the square root of 2 is 2, and we are left with a rational expression in simplest form where we have no perfect squares under a radical sign, we have no fractions under a radical sign, and we have no radical in the denominator. Here's a couple for you to try. I want you to pause your video and do those, and I'm going to pop the solutions up here, which you should also have on your PDF that I sent you. We're going to rationalize that denominator by multiplying by the square root of 7 over the square root of 7. Apply your product of property rules, and there you get it in simplest form. And the last one, you can freeze the screen and look at it. You multiply by the square root of 3b over the square root of 3b. You're going to work that out with your product property of radicals, and it's going to come down to here. Follow that through and make sure you read your textbook.